Okay, good morning, all of you. So we'll start. The discussion, and of course, we'll continue the discussion with wave shaping circuits. So let me just take few examples that what I given for assignment. Okay, most of the questions you could able to solve, and there are some questions where you find it difficult. Shall I take up the question number 2, which was something like this? Can somebody unmute? Am I audible? I think I'm audible there. Okay, whom shall I take? Maulia, can you unmute? Hello. Hello. Mm, just one of you respond. Okay, am I audible or not? Okay, let us write the two equivalent circuits when diode is on and off. So when diode is on, we will write the expression or the circuit diagram would be something like this. So it will be short circuit. This is when it is on, then it is 2 volt. This is R, this is V, this is 1 kilo ohm. When D is off, I will have this as the equivalent circuit. So this is 2 volt and this is R is equal to 1k. This is Vn and we are supposed to know V naught. Can somebody unmute? Mauli, are you not there? Hello. Bhavyashri? Bhavyashri, are you there?
Yes, sir.
Okay, we will see. Is these two circuits fine when diode is on, when diode is off?
Yes, sir.
Okay, can I write V naught is equal to 0 volt here and V naught is equal to V in minus 2, the output voltage?
Yes, sir.
How do I write for the second case V naught is equal to V in minus 2? How did I wrote it?
We
No,
off.
you simply write a KVL for this loop. So if you write the KVL for this, okay, suppose you consider this as minus plus. Since it is open circuit, the current is 0. There is no drop here, so there is only one voltage here, and you have this V naught. Am I correct?
Yes, sir.
So if you consider this as negative, it is minus V in plus 2 and then plus V naught is equal to 0. Am I correct? This is your KVL, Kirchhoff voltage law. Suppose you consider the voltage rise as negative, the voltage drop is positive, and again voltage drop is positive. So if you want to write what is V naught, so is it not equal to V in minus 2? This is how you're getting it. Most of you could able to write this, but most of you could not write when does this occur. So when does the diode turns on, when does the diode turns off? That is also very important to draw the output waveform and the transfer characteristics. So if you can see here, compared to this input voltage, can you see there is a minus 2 volt connected to this because of this battery?
Yes, sir.
So if the voltage, okay, at this point, what is the voltage you have at the cathode? Is it not 0 volt?
Yes, sir.
Here you have minus 2 volt, like because of this. So does this turns on when the voltage is 0 here? When this is 0, you have this minus 2, so it is off. So when does this will turn on? Assume that, okay, if it becomes greater than 0, it turns on. When does this will become greater than 0? Only when the input voltage is overcoming this 2 volts. So this is possible only when V in is greater than 2 volt. So when the input voltage here, whenever it whenever it overcomes this reference voltage, then only this diode turns on. So till that point it is in off condition. Correct? Here
Yes,
when V in is less than or equal to 2 volt. Correct?
Yes, sir.
So this is also important because most of you could able to write only what is the output voltage over here and here, which is very easy to write it. But you have to also write what is or when does this situation will occur. So this will occur or this circuit will look like this when the input voltage is more than 2 volts. Suppose if I write the what the time response of it. So this is my input voltage. I'll write the rotate one. This is T. This is now V in. Let me write a reference voltage of 2 volts here. So this is my 2 volt reference. So let me just drop lines, okay, wherever it is crossing the 2 volt line. Correct?
Yes,
So
sir.
is this region above 2?
Yes, sir.
So what is the output then?
About to on.
Here. When it is above 2, is it on there?
Yes, sir.
What is the output?
Output
Here.
greater than 2.
See. When the input is more than 2, what is output? Because I'm supposed to write the output. So is the output equal to 0 there?
Yes, sir.
This is 0, no? Correct?
Yes, sir.
Here also it is 0. So
Okay.
during this region, here it is on, here it is on, here it is it off here?
Yes, sir.
So assume now what is the voltage here? It is 2. Am I correct? The input
Yes, sir.
voltage is 2. What is the output voltage when diode is off? It is V in
Diode
minus
is
2. So what is the value of V in here? Is it not 2 volt there?
yes, sir.
What is 2 minus 2?
0. 0 volt.
0. So when the input voltage is 0, what is V naught?
V
0
naught is
minus
equal
2.
to
No,
0 minus
0 minus 2 is minus 2 volts. So does it mean that your output is, when the input is 0, output is at minus 2. When the input is 1, output is at minus 1. When the input is 2, output is 0. Will it go like this?
yes, sir.
And then here it just goes, you can see, suppose if the voltage here is something like minus 10 volt, the input voltage, what will be the output voltage? Suppose the input is minus 10 minus 2, what is this? Minus 12. Where does this minus 12 come? Will it come below that?
Yes, sir.
So just a minute, I'll use a different pen. It goes like this. It is constant. You can see it is coming down here like this. See now? This is how it
Yes,
goes.
sir.
If I write the transfer characteristics, so I want some of you to talk. Suppose if you have any difficulty here. What is this dotted line? What is that dotted line? Dotted line corresponds to input equal to output. Correct? So
Yes, sir.
anything above 2 volt, what is the condition of your diode?
Diode is on.
Anything below 2?
Below 2 is off, sir.
Is this below 2? Is this above 2 volts?
Yes, sir.
Correct? If it is above 2 volt, what is the output voltage?
About 2 volt. Output voltage is 0, sir.
Shall I write 0 here? Correct?
Yes, sir.
If the input voltage is below 2, what is the output? This is V in. This is V in. So V in minus 2. So V in minus 2, this is V in, which is 2 volt. Assume that this is now 2 volt. So what is 2 minus 2? It is 0. Can you see the output voltage is exactly in parallel with your input voltage, but it is below 2 volts. If this is 0, this is minus 2. If it is minus 2 here, then this is minus 4. Correct?
Yes, sir.
See here, this is output same as input, but here output is less by 2 volt. That's what is shown here. That's what is written here. You will going to have a parallel line along with your input, but this is down by 2 volts. This is down by 2 volts. So does this parallel line indicate V out is V in minus 2?
Yes, sir.
Correct?
Yes, sir.
Okay. Any doubt to anyone at this point of time? Hello.
Sir.
Shall I go to next or what?
Yes, sir.
Okay. We'll go to anybody. Okay. I will go to one more different circuit. Okay, which is having two levels. That is exactly this circuit. This is 2. This is 3 volt. This is 1K. Let me call it as D1, D2. This is V in. You taking V0 here. Correct. Now, can you see? Is there any possibility that, okay, because when you had only one diode, we could able to write two combinations when diode is on, diode is off. Correct.
Yes, sir.
Now the condition here is you have two diodes. So do we, how many combinations you think of having? So is there any possibility that both the diodes can be turned on simultaneously? See,
No, sir.
during positive half cycle, what is the condition of this? See here,
Diode is on.
see, forget about that. You assume that input voltage is 0 volt. If the input voltage is 0, what is the condition of this diode?
Diode is on, sir.
No, how it is on, I say. When this is 0, here you have 0 volt. For N, you have positive voltage. Is D1 off?
Yes, sir.
How about this? Can you see this is 0 here? 0 volt is going to the cathode. At the anode, you have negative voltage. Is it on?
Yes, sir.
Hey, ಹಿಂಗ ಮಾನ ಆಗುತ್ತೆ. It will be on only when P is greater than N. How much is P here? Minus 3. Minus 3 here
Minus.
it is 0 volt. We are assuming it as 0. If this is 0, both the diodes are off. So one of the equivalent circuit we have to write is, so when D1 and D2 both are off, how it looks like. Correct?
Yes, sir.
So when both are off, how does the circuit will look like? Is it something like this?
Yes, sir.
I don't know whether you are writing or simply watching like a movie. Can I see somebody's notebook? Who is there? I don't know the name. Ankita, are you there? Is there anybody with by name Ankita? Or
Yes, sir.
okay, Ankita, show me what is your writing? Can you share it?
Yes, sir. Yes, sir.
Yeah. Can is it possible you can able to share your thing?
Is it visible, sir?
I don't know how you are sharing it. No, forget it. Okay, Hari Prasad. Hari Prasad.
Yes, sir. Yes, sir. I,
Okay, fine. It's not for my satisfaction, just to make sure that you're all learning. Okay, fine, leave it. Is this is one of the possible? Sorry, is this is the equivalent circuit when both diodes are off? Hello, hello. Who was there with me?
Sir.
Yeah. Is this the equivalent circuit? Then if both are off, what is the output voltage?
0.
How come I say this is open, no current is flowing through this, no current is flowing through this is 0, this is 0, no drop here, this is 0 voltage drop. So if you write the KVL, input voltage is exactly coming out here. So there is nothing drop, nothing is going here. So V0 is equal to V in. It is not 0.
Yes, sir.
When it will
No.
be 0, when you have something like short here. So if the output is connected to ground, you will have a 0. You will have a 0 here. Now output is measured here, no? When the output is measured here, it is with respect to this. So it is like, okay, it is this terminal. So what is the voltage you have? Voltage you have is 0 drop. So why there is no drop here? Because the current is not flowing through either this path or this path, because current is equal to 0. I will have V naught equal to V in. Correct?
Yes, sir.
Okay. Next, let us consider a condition during the positive half cycle. So during positive half cycle, is there any possibility that this D1 can turn on? Okay, when does the diode turns on? As we discussed earlier, if the voltage at anode exceeds voltage at cathode, in an ideal case, then diode turns on. What is the voltage at cathode here? Hello,
2 volts.
2 volt. If the voltage at the anode exceeds 2 volts, does this D1 can turn on?
Yes, sir.
Okay, during that point, what is the condition of D2? Because you can see when you are there in the positive half cycle, does the entire positive half cycle make this D2 always off?
Yes, sir.
So if you consider this, okay, positive half cycle, if you consider this entire positive half cycle, or so shall I say the entire positive half cycle D2 is off?
Yes,
Correct?
sir.
Is D2 is off? Why D2 is off?
Yes, sir.
Why it is off?
Voltage
Because it is reverse biased.
reverse biased.
This is 2 volt. Correct? If the input voltage exceed 2 volts, does D1 turn on here?
Yes, sir.
So D1 on, D2 off. Correct?
Yes, sir.
Here both are off, because anyhow D2 is fully off. So is D1 is also off here.
Yes, sir.
So here both are off. So when both are off, what is the output voltage?
V
It follows.
V naught.
When D1 is on, D2 is off. So we have to write the circuit. So now this is D1 on, D2 off. Shall I write the circuit?
Yes, sir.
I will write the circuit for this. Okay, this will be short circuit. This is open. This is 2. This is 3. V naught. This is 1K. This is V in. So this is when V in is greater than 2 volt. Correct?
Yes, sir.
Here this is V in is between 2 and minus 3. So between 2 and minus. Correct?
Yes, sir.
So when it is more than 2, what is V naught?
More than 2 volt.
What is V?
V naught.
What is V out? Just see here. How much the voltage that you see from here to here? Because you have a battery. Is V naught equal to 2 volts? Hey, come on. So what is the voltage that you are seeing with respect to ground at this point? Is it not the battery voltage?
Yes, sir.
So it is 2 volts. For
Yes,
any
sir.
voltages beyond 2 volt, output is 2. Correct? Shall I
Yes,
write
sir.
this as my output over here? So for less than that is the output following. And then here it is less than that, output is following. So do we have one more reference voltage that is minus 3 volt?
Yes, sir.
So if the input voltage is more negative than minus 3, is your okay, let me first take the entire negative half cycle. Does the entire negative half cycle your D1 is off?
Yes, sir.
Why it is off?
First
Entire negative half cycle, why D1 is off?
one less than 2 volt.
One second.
It is less than 2 volts, sir.
One second, I'll come to you. See. Come again. See, during negative half cycle, so is D1 reverse biased?
Yes, sir.
So if it is reverse biased, then it is off. That's why you can see for the entire negative half cycle here, for the entire negative half cycle, am I writing it as off? Hello. So for the entire negative half cycle, D1 is off. Again, when does D2 turns on? D2 can turn on only when the input voltage is more negative than compared to minus 3 volts. So it is only over here during this region D2 is on. So I will write D2 on here. So this is the voltage at which D2 is on. If D2 is on, and of course D1 though anyhow it is off during the entire negative half cycle. Shall I write one more condition where D1 is off for the entire cycle and D2 is on? When does this will happen? When V in is lesser than minus 3 volt. When V in is lesser than minus 3 volt. So I will write the equivalent circuit now. This is when D1 off. Okay, now this is off. This is 2 volt and this is on now. This is on now and this is 3 volt. Don't write again minus 3, simply write it as 3. This is R is equal to 1K. This is V in. So what is V0 now? Is V0 equal to minus 3 volt? When D2 is on, this is D2 is on. So output voltage will become minus 3. So you'll end up with you just continue. Correct?
Yes, sir.
If you want to write the transfer characteristics, I will write it here only. I will write it as 2. This is minus 3. I will write a dotted line. This is V in. This is V0. Let me just draw that demarcation of 2 and minus 3. So here anything above this D1 is on. Here D2 is on. Here D1, D2 both are off. Here
So,
D2 is okay. Here D1 is off. Okay, when both are off, we will going to get V0 equal to V in. Exactly, that's what you're getting. Let me just write it. V0 equal to V in. That is when it is both are off. If D1 is on, we will get the output voltage as 2 volt. It is constant. If if D2 is on, output voltage is constant at minus 3. You can see it is minus 3 for any voltages below minus 3. It is minus 3 volt constant. Correct? So it is a
yes, sir.
double level clipper. So I can change the clipping level to 2 volt here, and then it is minus 3 volt. If you are changing this voltage, this is going to move up and down. Okay.
Yes, sir.
Let me just prove one more circuit. I'm just looking at some queries from any one of you. So if you have any queries, let me just clarify that. Let me write one more circuit where now is there any possibility that both the diodes can be turned on in this particular case? Because we wrote only 3 combinations, both off, one on, one off. In the other case, it is the one which was on, now it is off here. So there is no such situation comes where both the diodes are on, when both the diodes are on. So that is a particular situation which will never occur for this particular circuit. Of course, we can just see in future a combination a circuit where when both the diodes are on. So let me write the one more circuit where you had the diodes are actually in parallel. So I have a diode going like this. There is one more diode which is connected this way. Then I have this is V0. This is D1, D2. This was 1 volt. This is V in V0. Correct? V1K. Shall I write again 3 combinations when both D1, D2 or both are off? D1, D2 off. If both are off, how it look like? This is also open. This is also open. What is the current that is flowing now? Because both the diodes are off, the current is I equal to 0. So there is no drop. V0 is equal to 0 volt. V0 is equal to 0 volt when both are off. This will happen. So when does this will happen? So is this D1 off for the entire negative half cycle? Here, when does this will conduct? This will conduct for voltages below -1. So this will happen for all voltages V in greater than -1. For any positive voltages, for any voltages greater than -1, this is the condition what will going to exist. Meaning, if I write this as my input waveform, this is my input waveform here. So this is -1 volt. I will write the reference here. Any voltages, of course, this is that intersection point. This is that intersection point, and suppose if it goes down here. So this is again the intersection. So this is input voltage beyond -1. This is the case where D1, D2 both off. This is now D1, D2. Oh no. So during positive half cycle, okay, now during positive half cycle this will be on. Okay, when does the diode will be off? So during positive half cycle is it on? Because during positive half cycle here it is 0. Whenever the voltage goes above 0, now it is between uh, okay input voltage less than 0 and -1. So this is the condition. Correct? If the
Yes,
input
sir.
voltage is more than 0, this is on, because you can see there is no battery here. So since the input voltage anything because the cathode is grounded here, there is no drop here, so any positive voltages above 0, this will go to turn on. So shall I say this is 0 here, we'll write this is 0, again this is 0. So okay, this is not the condition. This is the region where both are off? Correct? Only in this region
Yes,
both are
sir.
off. Correct? In this region
Yes,
both
sir.
are off. You have during that point, what are the output voltage? What are the output voltage? This is not the
Output.
condition. If input is between 0 and -1, you have a 0 and -1. Between 0 and -1, both are off. If both are off, V0 is equal to 0. I can also write the transfer characteristics. Okay, let me write the transfer characteristics here. Unless you people think yourself and then start exploring the thing, even if I explain for 100 circuit, 101 circuit will be different. This is 0, this is -1. So during this region, output voltage, okay, both the diodes are off. This is D1 as well as D2, both are off. If both are off, I know that the output voltage is 0. Output voltage is 0 here. Then anything above 0 here, is the diode D1 on?
Yes, sir.
D1 on, D2 off.
Oh,
For that, what are the equivalent circuit? Shall I write the equivalent circuit for that? So is because D1 is above 1, so this is now short circuited. You have this is still open. This is okay. I will write the battery here. This is now open. So this is now what is V0? What is V0 here? This is V in. This is connected to V in? Can you see here? Is this almost connected here? Can you say this V0 is shorted with V in?
yes, sir.
So is not V naught is equal to V in,
Yes, sir.
meaning it follows. It just follows the input voltage. Whenever D1 is on, D2 is off, it follows the input voltage. It follows the input voltage here, then it becomes 0, and then it is okay. This is when V in is greater than 0, correct? This is when D1 on, D2 off. Let us consider the condition where D1 off, D2 on. When does this condition will occur? When does D2 will turn on?
D2 is
It will turn on
what?
if the input voltage goes below -1. Below -1. So this is the region where D2 is on, D1 is off. So in such case, how does the equivalent circuit look like? This though it is off. Here it is 1, something like this, and you have, what is this? This is short circuit, V naught. This is V in. This is resistor. So what is V naught? Is it not
Minus.
equal to V in plus 1 volt?
Yes.
If it is plus 1, how it will look like?
Plus.
Hmm?
Up.
Okay,
Sir,
we'll write it for this D1 on. So is it going like this?
Yes, sir.
Here anything less than -1. So is output voltage V in plus 1?
Yes, sir.
V in plus means it will just go parallel with this, but it is above 1 volt. This is above 1 volt. But I've seen the previous case, it was going below because the output voltage is V in -2. So whenever it is -2, it is parallel with the input voltage, but it is below. But here it
No.
is above this dotted line because output voltage is V in plus 1 volt. So whatever point you measure, this is 1 volt. It is V in plus 1 is your V naught. So this is V naught. This is V in. So what is V naught? It is V in plus 1 volt. So that will happen for voltages less than -1. Correct?
Yes, sir.
Okay, how does this look like? This will look like this. Of course, this goes like this. Can you see there is a output voltage 0 between -0 and -1. 0 and -1, it will be flat. Okay.
Yes, sir.
Okay, let me just ask you people, how do we write a circuit diagram from a characteristics? So assume that I have a characteristic something like this. This is V in, this is V naught. Assume that I have this as my dotted line. I want to get this type of, okay, assume that this is 2 volt. This is also 2 volt. Can somebody give me which circuit will give me this type of characteristics? Whoever shows me now, he or she will get it 5 marks for T2. I want the circuit diagram for this transfer characteristics. Of course, I'll just give you, maybe I'll do it for this for you people now. So maybe later you can try for this. Can you see the output voltage is constant 2 volt?
Yes, sir.
So that too, when it will happen? When it will happen? For the entire negative half cycle, is it plus 2 volt?
Yes, sir.
Even for positive voltage up to 2 volts, is it 2 volts?
Yes, sir.
So when do you usually get a constant voltage of 2 volts? Whenever you have a battery, correct?
Yes, sir.
So what I'll do, I'll put a battery here of 2 volt. Correct?
Yes.
I'll put a battery of 2 volt. When does this will be 2 volt? When do you get the output voltage as 2 volts? During negative half cycle, correct?
Yes, sir.
Correct. So shall I do something like this now?
Yes, sir.
During negative half cycle, suppose now if I consider this as my circuit, during negative half cycle, is this on?
Yes, sir.
Is it on? Uh,
Yes, sir.
why it is on during negative half cycle? Why it is on during negative
Sir,
half cycle? Because during negative half cycle,
because
this is negative, this is positive, so that is what is favorable for your diode to turn on.
yes, sir.
So it is in on condition. If it is in on condition, shall I replace it by a short circuit?
Yes, sir.
If it is short circuit, what is the voltage? Is it not 2 volt?
Yes, sir.
This will be 2 volt as long as this diode is off. Sorry, as long as this diode is on.
On
Till what input voltage this diode will be on?
two.
Unless this reverse biases. This will reverse bias only when the voltage at cathode exceeds the anode voltage. So that will happen if the input voltage is more than 2. If the input voltage is more than 2 volt, this turns off. When this turns off, your output is equal to input. It is following.
Yes, sir.
Correct?
Yes, sir.
This can be 1K, and of course you will get V naught. Will it make sense?
Yes, sir.
Okay, what I'll do, I just write this circuit. This is -3. This is now -3 volt. On x-axis you have input. This is V naught. This is of slope 1.
Sir, explain previous circuit again, sir.
Perfect. Where do you need the explanation? Okay, let me start from the beginning. So why I wrote first battery? I wrote a battery because my output voltage should be 2 volt constant. Correct? Because we know
Yes,
that we have learned from the previous examples. Whenever a battery comes in shunt, I will going to get a constant voltage. Correct? Suppose when the
yes,
battery
sir.
is coming over here, can you see the output voltage was either less or more than the input voltage?
Yes,
Was
sir.
it above and below this reference line?
Yes, sir.
So when it was coming like flat, it was coming like a flat DC voltage when you have a battery. Correct?
Yes, sir.
Here, can you
Yes,
see this was -3, this was +2 volt because of this battery?
yes, sir.
Because my characteristics requires a 2 volt, so that's why I write a battery of 2 volts.
Yes, sir.
Next, I started looking at, so up to what all voltage this is 2 volts. Can you see during the end, because this is 0 no, this is 0 volt, this is negative half cycle of the input, because this is my x-axis, means this is 0, this is positive half, this is negative half.
Yes, sir.
So during entire negative half cycle, can you see this is 2 volts?
Yes, sir.
That should happen. Of course, this should be the condition during the entire negative half cycle. Meaning, I have to put a diode which will turn on for the entire negative half, even when the input voltage is 0. So in this
Yes,
particular case, if I put the diode in this direction, even when the input voltage is 0, is the diode on?
yes, sir.
Why it is on means this is 0, here it is 2 volt, so anode is greater than cathode, even with a 0 voltage it is on. If it is
Yes, sir.
-1, -4, -5, what is the condition of this diode?
On, sir.
This is 2, that is -1, -2, -3, -5, it is still on. So it is keep
Yes,
going
sir.
like this. Is the output voltage constant at 2 volts?
Yes, sir.
So this part is fine. Okay, how about this extension till 2 volts? Because even when the voltage is 0.5, 1 and 1.5, is the diode still off? Sorry, is the diode still on?
On, sir. Yes, sir.
When the diode is on even for the positive half cycle till 2 volts, what is the output voltage? This is
Output
on.
voltage. Yes,
This is
sir.
on. If it is on means short circuit we are assuming.
Yes, sir.
Is the output voltage equal to 2 volts even up to 2 volts of your input positive voltage?
Yes, sir.
That's why this will continue till input of 2 volt. If the input exceeds positive 2 volts, positive half cycle, what will be the condition of this diode?
Off, sir.
If it turns off, then what is output? How does the equivalent circuit look? So does the equivalent circuit look like this? What is the output voltage now? ಏನಾಗುತ್ತೆ? What is V naught now? There is no current.
Win, sir.
V in. It's following. It's following. It is following on that line, no?
Yes, sir.
This indicates V naught is equal. If the slope of your output is if it is a slope of 1 where the output is equal to input, this is a condition. That's why it is
Yes, sir.
following. Correct?
Yes, sir.
Try for this. Keep in mind, when does the output voltage is constant and what is that voltage? What is the output voltage? That do you have a constant output voltage somewhere?
Yes, sir.
When?
Minus.
When? Okay, minus 3 volt. When does it is constant? Identify which is
Battery.
positive half cycle, negative half cycle. This is 0. This is positive half. Of course, no need to say that. That should be understood. This is negative half. Because this is 0 means it is positive voltage, negative voltage, no?
Yes, sir.
So, even during positive half cycle is output voltage minus 3.
Yes, sir.
Even during negative
Yes,
half
sir.
cycle for some duration, output voltage minus 3.
Yes, sir.
So, shall I put a battery of something like this orientation? Okay, and I have to have a diode. What should be the orientation of the diode? You can see for the positive half cycle, diode should be on.
Yes, sir.
Okay, but how do I put it? Is it P or N? Shall I put it like this?
Yes, sir.
Will this work?
Yes, sir.
This is a circuit. Okay.
Yes, sir. Yes.
Okay, let me write it for some other circuit. Okay, some other plot. This is V naught, V in. It's always necessary that you should write a dotted line. That will give you a reference of your input voltage. Okay, I will. Can you see now? Is the output line below that reference line or above the reference line?
Below, sir.
If it is below, what is V naught is equal to? Is V naught is equal to V in minus 3?
Yes, sir. V
So,
minus
if
3.
it is V in minus 3, can I write the circuit as something like this? Because this is my input voltage. This is resistor. This is V in. This is 3 volt. Correct?
Yes, sir.
Then where I should put the diode? Of course, diode is here. Now the what should be the diode direction? Okay, when does this is true? When does this is true? When do you get this? When does the output voltage is V in minus 3?
In positive half cycles. Negative half cycles, sir.
Negative half cycle, and diode should be what? Off or on?
Off, sir.
Diode should be off. How do you make
Off.
it off during negative half cycle also? Now I need to write the direction. No, I need to write the direction of your diode either this way or this way. Either I have to put this or this. Which one shall I put?
Sir, P to N.
Okay, let me write it as okay. 1, 2 choice. Which choice you pick?
One.
Sir, 2, sir.
One.
Is it choice 1? Because see now, keep in mind, during negative half cycle, the diode should be off.
Yes, sir.
Shall I put one choice or second choice?
One.
One.
Shall I put the choice 1?
Yes, sir.
If I put the choice 1, that is this diode, is the diode turned off during negative half cycle?
Yes, sir.
If it is off means output voltage is input minus 3, which is this.
Yes, sir.
This is true even during positive half cycle up to 3 volts.
Yes, sir.
If it is above 3 volts,
About 3 volts, so.
this turns on.
Yes, sir.
When this turns on, output voltage is 0.
Yes, sir.
So that's what you're getting. Correct? Sir, CS amplifier was so easy. CG amplifier was so easy. So this is becoming hell of a difficult. Correct? Now, of course, what requires is you need to clearly find out what is the output voltage you need and how do you achieve it. Correct? Always when you're learning new topic, the older topics always looks easier or the present topic looks very difficult. Maybe when I just teach differential amplifier, you will find okay, this itself is very easy. It's always like that.
Yes, sir.
So always the return paths of any journey is easy, no? Whenever you just come back from you go anywhere, so your return journey looks always very fast. Now this is of our journey of your what wave shaping circuit, it is looking so hard. When you just revise it, it is so smooth. Am I true? Always your return journeys are easy.
Yes, sir.
Because now you're in the forward journey, it is looking so difficult because we don't know the exact journey path. So that's why it looks everything is scarier. We don't know how the roads are, whether it is okay, uphill task, whether it is down or so on. So now once you get used to it, then you can easily uh, drive the circuits. Correct? Okay, let me just try out this particular thing. If I want to have hmm. Okay, by the way, can you able to write the circuit, sorry, the wave shape, okay, waveform for this? The equivalent waveform of this would look like this. Suppose if I write this is my input waveform, which is going from some positive to negative voltage. If you can see here, I want to have this as my reference points. So if you look at this, I have to get a waveform which is exactly okay. This is my input waveform what I'm applied. I have a reference voltage, one at 1 volt, other at 4 volt. I have to get an output waveform which is if the input voltage is more than 4, it is 4 volt. If it is between 1 and 4, it follows. If it is below 1 volt, it is 1 volt. So this is 1, this is 4 volt. This is would you like to have batteries in the shunt path or series path?
Shunt bulb.
Perfect. Shall I put two batteries with both positive voltages 1 volt and
Oh,
4 volt?
4 volt. Yes, sir.
Is it done? At
Yes, sir.
least we are now convinced. Now I need to put two diodes. Of course, let me just also write input voltage. So let us first write the skeleton. Correct?
Yes, sir.
Now let me write this is my V0. So I need to put two diodes. What is the direction? Okay, let me write these two diodes. This is one diode. This is the other diode. So this is 1, 2. Which one shall I put where? Okay, this is the slot available. Where shall I put 1? Where shall I put 2?
Sir, 1 at first.
1 at first. 1 at first. Okay, if I put 1
1.
at first, does the diode turns on at 1 volt itself for the positive half cycle?
Yes, sir.
So what should happen? So if no, it should what should happen during negative half cycle? Negative half cycle diode should be on. One diode should be on, which is connected to a battery of 1 volt. Keep just have a look at this point. Is the input voltage less than 0 here?
Yes, sir.
This is negative half, no? This is negative half. During negative half cycle, one diode should be on. That should be connected to 1 volt battery. Okay, out of these two, diode 1 and diode 2, which one will be on for negative half cycle? Suppose if I put it as it is,
2.
shall I put this here?
Yes, sir.
So if I say it as D2, is this D2 fine? During negative half
Yes, sir.
cycle, this to on, because it is anyhow it is on. During negative half cycle, turn on. Correct?
Yes, sir.
How about this? The other one. Correct?
Yes, sir.
Getting some confidence. Hopefully
Yes,
so.
sir.
Okay, maybe I'll just go to few circuits. Okay, one, okay, not issue. One care that you have to take while doing the LT spice simulation is that the voltage here is never 0 volt. It is 0.6 or 0.7 volts. Suppose if I want to just simulate the same circuit with 1 volt and 4 volt, or then this will not be exactly 4 volts. So this will become 4 plus V gamma. This will become 1 plus V gamma. This will become 1 plus V gamma. This will become 1 plus V gamma is the cut-in voltage. Correct? So that is the one small change you have to keep in mind whenever you are simulating this in your LT spice. Otherwise, it is perfect. So whatever transfer characteristics you have, you'll get the same shape. Only thing is that this is not 1 volt, maybe 1.6. This is not 4 volt. This is 4.6. The output voltage is 1.6. Here it is 4.6. Here it is exactly following, and it will be a straight line. Let me just go there and then try to simulate one such circuit. Not this one. Let me just see. Was it circuit 4? No. Let me just. I just simulated all the circuit that are given for simulation. Not 5. Let me just go to 6th. Yeah, perfect. Let me take this one more battery. So where is that battery? Battery F6 is copying. Control R, rotate twice. What was the positive voltage? Okay, let me share this. Sorry. What is the positive voltage? Positive. Okay. Oh, both are positive. Okay, let me just rotate this again. Control R. Oh, let me take out this. Okay, I will pull this to this. Okay, let me just take this FFF7. Uh, what should be this diode D1? Suppose if I say this is D1, is this 4 volt here?
Yes, sir.
Let me make it 4. This should be 1. Correct?
1 volt. Yes, sir.
don't expect the output voltage to be exactly at 1 and 4. It will be 1.4, 1.7 and 4.7. Shall I run it? Actually, I am just running it here to see the transfer characteristics. You can see I am just putting a dot DC V2 minus 10 to 10 with an increment of 1 volt. If I save it and then run, okay, let me remove the other circuits. Okay, and I'll take out this also. Where is that? I'll take out this. Okay, is this my circuit? Okay, this is my circuit. I'll pull this up here and put it here. Correct? You can see both are positive. One diode is in this direction, other is in that direction. Okay, let me run this. Let me see what is the input. Can you see this is that dotted line?
Yes, sir.
This is that other one. So let me just make this different color. Where is that different color? It is this. I make it red. Now you can take a cursor on the input line. As I said, this will happen at 4.6 or 7. Can you see here 4.6, 4.7?
Yes, sir.
Even though we kept a battery of 4 volt, because another 0.6 volt is required to overcome that what voltage? Cut-in voltage. Okay, that's why it is so. Just I don't know why it is not running from. Okay, can you see now? This is running from minus 10 to plus 10 volt, minus 10 to plus 10 volt. So any voltages beyond 4.6, output voltage is constant at 4. Can you see the output voltage is still at 4? Sorry, it's at 4.7 or 4.6. Can you see here? It is 4.67.
Yes, sir.
For input voltages beyond that 4.6. Same thing is true on the negative half. Can you see the negative half for any voltages less than minus 1.6? Can you see it is minus 1.6 here? Where is that? Where is that? Oh, sorry. One difference I'll just make it here. Okay, it's good that okay, I could able to make you people observe. So this is 1 volt. This is actually minus plus 0.7. So this will happen. Okay, what is the effective voltage now? This will not be 1 plus V gamma. This is actually 1 minus V gamma, because you have the battery and these are in opposite direction. Suppose if the battery was negative positive, then it would have been minus 1 plus of V gamma. Since this is positive negative and this is negative positive, this is positive negative, the voltage that you will get is 1 volt, which is the battery, minus V gamma, which is 0.6. So it will be 0.4. That's what you are seeing here. Can you see here? This is not exactly 1.7. This is at around 0.4. Can you make out this?
Yes, sir.
And what is the output voltage? The output voltage is also not 1 plus V gamma. It's actually 1 minus V gamma. So this is not 1 volt, or it is not 1 plus V gamma. It is 1 volt minus V gamma, which is 0.3 or 0.4 volts, maybe 0.36. That you can see here. Can you see here what is the voltage? Okay, let me just put it on the. Can you see how much is that? 304. 304 millivolt. That is 0.3 volt.
Yes, sir.
0.3 volt is coming from 1 minus 0.7. 1 volt is of your reference, minus 0.7 is of your cut-in voltage, which is put in the opposite direction.
Yes, sir.
Correct? Suppose if I make the battery reverse, where shall I go? Sorry, 1 second. I'll make the battery reversed. I'll make this equal to minus 1. When I make it equal to minus 1, the voltage, now you can see I have made this equal to minus 1, means I just made it something like this. When I make it like this, so the voltage is of course it will come down here, it will come down, it will go like this. So what is the voltage now? It is minus 1 minus of V gamma, which will be minus 1.6 or 1.7. That you can see. I'll show you that also. So you can see I made it minus 1. If I run it now, can you see now this red one which is there here? Can you see it is now minus 1.7?
Yes, sir.
That's it. So whatever voltage that you get purely depends on what is the polarity of your V gamma and the reference voltage. Here you can see it is minus plus, here also it is minus plus because you have a minus 1 volt. Correct? Here it was plus minus and plus minus. The voltages will simply add here.
Yes, sir.
Okay, we will see few more such circuits in the coming classes. Thank you.